Welcome to the deep dive. Today, we're looking at something, well, really fascinating, how the principles behind software creation, specifically object-oriented programming, might actually give us a new way to understand how technology itself evolves. We'll be digging into this using the idea of Taxshila technology and its 7 phases of learnography and knowledge transfer.
It's a really compelling idea, yeah. The material we've got suggests that these core concepts for structuring software, OOP principles, they can act as a surprisingly effective framework for grasping how technology progresses.
Okay, Taxshila technology, 7 phases. It sounds pretty involved. But how does coding, the nuts and bolts of OOP, connect to all this?
Our sources are pointing to 4 main concepts: encapsulation. Then there's derivation, which they use instead of inheritance, polymorphism, and abstraction. And apparently these aren't just for software now. They're relevant to hardware, even how knowledge moves within this Taxshila system. Absolutely. Yeah, the sources we've looked at really stress that OOP offers a, um, a structured, modular, and this is key, an adaptable way to see how Taxshila technology develops through its lithography process. It's about spotting the similarities, fundamentally, between building complex software and the way technology seems to grow and change almost organically.
So this isn't just like a neat metaphor. The sources are suggesting a real functional connection between OOP and how knowledge actually gets transferred in these 7 phases.
Precisely. The argument is that by applying these principles, we can understand better, maybe even anticipate, how things like modularity, reusability, and maintainability develop, not just in code, but in the actual physical development of Taxshila tech. Think of it like a common language, maybe, for describing how complex systems are put together, digital or physical.
All right, okay, let's peel back the layers then. Starting with encapsulation, the material links this to the definition and structure phases of Taxshila. What's the connection there?
Right. So encapsulation in software, it's essentially about bundling data and the methods that act on that data together into one sort of self-contained unit, a capsule. And crucially, it involves hiding the internal details, protecting them. The sources draw a direct line to those early Taxshila phases definition and structure. In those foundational stages, the focus is really on carving out these well-defined, protected domains for the key tech components.
Ah, okay. So, like, how you protect data in software so it doesn't get messed up accidentally.
These early Taxshila phases are about setting up strong boundaries, safeguarding the core tech right from the get-go. Exactly that. This compartmentalization, our sources say, is vital for keeping the technology sound, its integrity intact, and just making it easier to manage down the line. It builds that solid foundation for, safe, controlled development, much like good encapsulation in code stops unexpected errors and makes debugging simpler. You could also think about it as defining the interfaces between components clearly. Bad interfaces early on, big headaches later. Same in software, same here.
That makes a lot of sense. Okay, next up is derivation, what we usually call inheritance. This connects to the cognitive, innovative, and formatting phases. How does building on existing stuff translate here?
Well, derivation, or inheritance,
Yeah.
lets you create new software blueprints, or classes, based on existing ones, right? The new one automatically gets the features of the old one. The sources suggest the cognitive, innovative, and formatting phases in Taxshila work kind of similarly. They take that encapsulated knowledge from the first 2 phases and they build on it. They inherit, essentially, certain hardware attributes or functionalities.
So the frameworks built early on aren't just static. They become the starting point for new ideas and refinements in these next phases.
Exactly. The material really points out how this allows for efficient adaptation. Reusing existing elements, just like reusing code, saves a lot of time and effort. It creates a kind of hierarchy where innovation builds on that stable inherited base. It cuts down on redundancy, fosters more logical evolution.
Interesting. Okay, then we get to polymorphism, linked to the Taxshila and intuitive phases. This is about things taking multiple forms, yeah.
That's the core idea, yes. In software, polymorphism lets objects from different classes respond to the same command, but in their own unique way. Our sources explain that the Taxshila and intuitive phases show this kind of adaptability. They let the technology evolve, branch out into different uses, integrate into various sectors, much like different software classes can use a common interface but do their own thing with it.
So the tech isn't stuck in one role. These phases let it become flexible, adapt to different needs, different situations. And that intuitive phase, does that imply the tech starts sort of understanding different contexts and adapting its function, like software handling different inputs?
Precisely. The sources even mention method overriding from software, where a subclass provides its own version of an inherited method, as, an analogy for how this works. This flexibility, this versatility that material argues, is what makes both software and Taxshila technology more resilient. Think about, say, a universal remote. That's the common interface. The power on button works, but the TV and the DVD player respond differently. That's polymorphism. In Taxshila, maybe that intuitive phase sees a core tech adapted for different tools, each responding uniquely. Makes you wonder, doesn't it, if the most successful technologies have always had this innate polymorphic quality.
Huh, yeah. Okay, finally, abstraction. The sources say this runs through all 7 phases. How does simplifying complexity apply across the board here?
Right, abstraction. In OOP, it's about boiling complex things down to their essentials, hiding the unnecessary details. The sources really stress this is fundamental for Taxshila tech. In definition and structure, it helps create those initial blueprints without getting lost in the weeds. Then, in the cognitive innovative formatting phases, it guides how modules are designed and refined, focusing on the core features. And later, in Taxshila and intuitive phases, it's what allows for flexibility and seamless interaction between parts, because the complex inner workings are hidden.
So it's about managing complexity at every step, letting people work with or use the tech without needing to know every single detail, like driving a car, maybe uses the steering wheel, pedals. You don't need to know combustion cycle details to drive. Abstraction hides that.
Exactly like that. The sources argue abstraction is really key to how Taxshila technology manages itself and evolves efficiently through the whole process. It promotes flexibility, makes it easier to grasp and use at different levels.
Okay, so pulling it all together, encapsulation sets the stage in definition and structure. Derivation drives growth in cognitive, innovative formatting. Polymorphism brings adaptability in Taxshila and intuitive phases. And abstraction is the constant underpinning everything.
That's the framework presented, yeah.
Yeah.
And the sources stress this isn't just theory. Applying these OOP concepts gives the real functional structure for understanding how Taxshila tech develops. It builds logically, from those contained units early on to how they evolve and interact later.
And the benefits. The material says you get the same things as good software design. Modularity, adaptability, a clear structure.
Wow, that's quite a connection. Saying how we build digital stuff mirrors physical tech evolution.
Exactly. That's the core insight from the sources. By seeing this link between OOP and Taxshila's evolution, we get, well, valuable ways to think about organizing, extending, and adapting technology in this fast-changing world. It's about recognizing these deep principles playing out, even in places you wouldn't expect. So, fundamentally, this deep dive suggests that object-oriented programming principles, encapsulation, derivation, polymorphism, abstraction, they actually give us a pretty powerful lens, a way to view the development, the evolution of complex tech like Taxshila and its 7 phases. And these principles help explain its modularity, its adaptability, its robustness, just like in software.
Right. And maybe that leaves you with this thought. Think about how fields that seem totally separate, like software design and the history of technology, can actually shed light on each other when you look at their underlying principles. What other surprising connections, might be hiding out there, waiting for us to find them if we just look past the usual boundaries?